Okay, somehow, so as far as CPP, concurrent and parallel programming concept is concerned, so I am supposed to consider this particular course for you right now from today onwards. So let us go ahead and take the class for this particular today. But today's class will be very precise class, which could be given just 20 to 25 minutes. Of course, I don't know how many how long it could be taken, but the 20 to 20, 25 to 27 minutes will be taken today. However, so what is the point which we have to consider as concurrent and parallel programming? First of all, we'd like to know something about concurrency. What do you mean by concurrency? And what do you mean by sequential execution, concurrency, concurrent execution, then parallel execution. These are the three different types of architectures which we have. So, I'd like to start right away from fundamental. The fundamental operation will be, our fundamental topic will be sequential. So let us check about what is the point of a sequential here, how the sequential is going to be gets taken into consideration. What are the points we'd like to take into consideration will be discussed today. So either sequential algorithm or sequential program or sequential, any kind of thing, process, program, algorithm, thread, whatever maybe, if it is might be executing in terms of a sequential mode, then it could be get start somewhere else. Somewhere else in the sense, if you consider your so C programming language, because whatever the programming language you have learned so far, for everything C programming language is the motivation. So that I'd like to take. So this is the start of C programming language. MAIN is the start of C programming language, and the open, so open brace, then followed by set of statements. Finally, it could be closed. This is the starting and this is the ending. Okay, start and finish. From right away from starting to finish, everything will be gets executed. Everything will be gets executed without other process execution. What is the meaning of this one here in the sense? What is the meaning of this particular sentence here? Without interleaving any other process. Interleaving in the sense, what do you mean by interleaving? While any process is being executed, let us consider this is the process which is being executed by a CPU. Then a CPU time will be, the whole time will be, let us consider this is the so graph. Within this particular graph, this is the time, and which is being executed by CPU. If this process will be during execution of this particular process, so no other process is being took place by CPU, then that is called as without other processing. If any other process, let me consider in the middle of this particular some 50% of process one. Let us consider this is process one here, and this is process two, for example. So process two here. If 50% of process one has completed, then interleaving gets happened. Otherwise, preemption gets happened here. So preemption will be gets happened by process P1, and it could be interleaved by another process P2. Then such kind of execution could be considered as some other way. It should not be sequential manner. Sequential manner is always to explain something like this. Sequential manner will be, so process one will be gets executed completely, and then after process one, process two will be get started. After process two, process three will be get started, and so on and so forth, and so on and so forth. In this way, the execution could be took place. As far as time is concerned, here to here, yes, process has been started and ended, and the second process will be get started and ended, and so on and so forth, will be called as the sequential. Okay, where exactly problem has been get started, otherwise algorithm has been get started right away from starting, and it will be reached to end. It must be executed. Otherwise, that could not be said in sequential manner. Okay, then so sequential operations will be done. One moment, please. Let me erase this one for our convenience. Okay. sequential process will be gets executed by any computer language, even so using functional programming languages or let me say Python or Algal, any language, whatever it may be, whatever the language it may be, you can consider. So all those languages could be implemented the sequential kind of operations. Okay, most probable operations will be, so most probable computer languages which could be satisfied for this sequential execution of programs will be third generation languages such as C, C++, Fortran, Java also third generation only, and the C++, Python, sorry, not Python, Pascal, Algal, Fortran, all these things will become under so third generation languages. So using these languages, you can develop, so what is that? Sequential programming or sequential processing. Okay. Then what is the specification here? Very important specification to be considered here is, so the program could be always executed with so single processor architecture. In the next slide, I will explain what is the single processor architecture, how this could be, and also give you some example how the things will be for the next point. Single processor architecture in the sense, so in our system, you do have only one processor. So if you consider Xeon processor, for servers, Xeon processor will be taken into consideration. If you take Xeon processor, so 4 different CPUs are incorporated within single system. So therefore 4 CPUs will be there. So then that is called as Xeon processor. So multi-programming, concurrent execution could be happen out there at Xeon processor. But in our general PCs in the sense of laptop or personal computer, if you consider them, only one processor, only one CPU in the sense microprocessor actually. Only one CPU will be gets incorporated within your motherboard so that you can perform so only one operation at any moment of time. Okay, so something like a single processor will be taken into consideration so that sequential operations will be done within that year. Let me explain in the next slide how the things will be gets happen. Then in single processor system and single processor architecture, CPU will be linked to random access memory and I/O devices through a common bus. Through a common bus, normally we have 3 buses will be there in any computer. The first one is a control bus. So control bus, otherwise a CB, address bus, address bus, and data bus. We have totally 3 buses will be there. Control bus will be always taking care about all devices which have been connected to that particular device, that particular computer. And second one, address bus is as and when if any instruction is being gets executed, then where exactly required data will be. To get that particular data, then so it is being identified where exactly the data will be stored in auxiliary storage device. And the data bus will be, after the identification of address of that particular data bus will be fetch that particular data from auxiliary storage device to the microprocessor for execution. In this way, so these 3 buses will be there. All these 3 buses will be called as common bus. Common bus. Okay. Through this particular bus, so we'll get the data which is being stored at auxiliary storage devices or random access memory also. Okay. Then it could be always sequential algorithm, sequential execution will be always executes a particular cycle of operations. These are the particular cycle of operations: fetching, decoding, and executing. So let me show you how this could be done through one familiar MS-DOS application, that is Debug. Okay, that is actually Debug is used to create some command files, .com files. So let me show you 1 or 2 examples. Let me show you how this could be done here. So this particular cycle, fetching the instruction and decoding that particular instruction and executing that particular instruction. So one instruction will be taken, for example, A will be equal to 10, that could be taken into consideration. So decoding in the sense, it could be high-level language to low-level language. How this could be done, I'd like to show you just a couple of minutes. Then you can see that. And executing that particular instruction. These three operations will be done continuously. And how these three operations will be based on which register these three operations will be done here in the sense, there is a register, that register is called as a program counter. Of course, in some other architectures, it is also called as instruction pointer IP. Either it is IP or PC. Okay, let us see whether our register will be available with IP or PC in our system. How that could be happen in our PC? Let us see. It could also be able to see by you. Okay, so these operations will be continuously gets happen. So if you want to execute some 1,000 lines in the sense 1,000 lines of code will be there with you. Probably all 1,000 lines cannot be the only automatic operations. There will be combination of logical and some looping and some selection kind of things. So fetching one particular instruction into microprocessor and can be decode them into the low-level language and can be executed. So then going to take one more. How much time it could be taken? This is one of the pitfalls. Fetching of data or fetching of instruction and decoding it and executing the thing, and whatever the output of that particular instruction, they may be stored into respective registers. Then going to fetching second instruction, do the same process. Going to fetch a third instruction, do the same process. You want to perform this one, how many units of time will be taken for execution of some 2,000 lines, 2,000 lines of code here. So this is the basic problem. Let me show you the example at this moment. Let me show you the example. Actually, in Windows 10, debug application is not there. So that is why I have loaded Windows 95. Windows XP. This is Windows XP. Windows XP has loaded for you to explain something. So through Oracle Virtual Machine, let me show you. Open CMD, and here you can type debug. If you have XP with you, 32-bit operating system with you, it could be okay. Through 64-bit operating systems, debug cannot be worked out. Okay, please okay. Look at this. Debug gets open. Look at this. A hyphen will be there with you. So small hyphen is there with you. Then debug prompt is there with us. Now let us examine what are the registers which are associated with Windows XP. I'm talking about Windows XP only. So to get the registers, okay, before going to take help will be to get the help of debug. You can see here. Assemble in the sense you have to write one particular program. Compare, range addresses will be gets compared. Dump, if you take dump, when any COM file is being executed, what is the dump? Of course, not exactly these are required for you. So let me show you how the registers will be. R will be, you can see R will be considered as a registers. You can type R and press enter, you could get here. AX equal to all zeros, BX, accumulator, base register, code register, and the data register, stack pointer. Hope that you have heard this particular stack pointer, base pointer, stack index, data segment, extra segment, stack segment, code segment. Now you can see instead of so here we have PC. I told you in some architectures it could be PC. In some architectures it is IP. Okay, so it is IP here. So let us see this one. So here it is IP, instruction pointer. What is the value of instruction pointer here in the sense? The next instruction which is being executed by the processor will be next instruction's address will be stored at this place. Next instruction's address will be stored at this particular place. Okay. So here I'd like to write some 5 to 6 questions, 5 to 6 instructions here for you. So move one particular value to accumulator, another value to base register BX, and apply for adding, apply for subtraction, apply for multiplication, apply for division. How these operations could be done, let us examine. So you can observe this one. DS, ES, and SS followed by CS. Code segment, stack segment, data segment, and extra segment will be referred same address 0B00. 0B00. So somebody has raised the hand. I don't know for why. I'll give you a chance to talk with me. One moment, please. One moment, please. I'll give you a chance to talk with me. So where it is? Probably I must come out from this particular meeting info. Okay. Yeah. So I have allowed to talk with me. I have allowed to talk with me 18. I think 18 is there with you. I don't know. Yeah, 18 is not there. Somebody has raised her hand. So please have a talk with me. Please have a talk with me so that I'll talk to you. I'll talk to you. Why you have raised the hand? Please talk with me. Some 18. Please talk with me. Why you have raised the hand? I'm speaking very fastly. That is the problem with you. All of you, please switch on your. Okay, however, so these are the registers information which have been connected to Windows XP. So here it is IP, instruction point. Now let me write a small program. So to write a small program at debug, we have to apply A. We have to apply here A in the sense assemble. You can see this is the segment address and this is the first instruction place. Okay, 0B00 is the segment address. You can see this one here. Oh, I'm sorry. You can see this one here. So 0B00 is address of the segment, and 0100 is, you can see here, IP address is the next instruction is being at 0100. So let me write MOV move. So X comma, let us consider some 10. And the second instruction is one more element will be gets taken as input here. Input is not possible here. Bx comma some 7. Then I'd like to operate add Ax comma Bx. What does it means? Ax equal to Ax plus Bx. That is the meaning of addition. So the resultant value will be at X. Then so MUL multiply Ax comma Bx. So Ax equal to Ax into Bx. That is the meaning of this one. Everything will be stored at accumulator only. Then divide. So Ax comma Bx. Okay. So this could be operated division operation. So after division, so you could get the direct remainder at X. Okay. Not exactly remainder. Remainder is going to display to you in Ax place. Okay, Bx. After completion of writing this one, apply for Control C. Then it will be show you the prompt again. Now, how could you execute this one? There is one particular statement which is used to trace this particular problem. Tracing is possible here. What is the tracing here? If you apply T, so you can observe what is the value of Ax before tracing? 0. Bx is 0, and then IP address is, instruction pointer address is 0100. So we have been started here 0100. We have started here and trace. You can observe this trace. It could be display the contents of registers as well. You can see whatever the value I am trying to store, it has been stored into Ax register. Okay, you can see Ax is previously it is 0. Now it has been stored with 10 here. Then again trace, you can see next instruction to be executed will be 103. Yes, it is 103. You can observe this one, it is 103. Now again go ahead with tracing. So move Bx equal move Bx comma 007. You can observe previously Bx equal to 0. Now 7 has been stored. Next instruction will be 106. You can see 106. Okay. Then again trace. Go ahead this one. So here add Ax comma Bx. Ax value is 10, Bx value is 7. Okay, it could be added and you can have 17. Next instruction will be 108. You can see 108 will be the next instruction. Now it is multiplication. The term is multiplication. Multiplication, so 17 into 7, that could be, the value which is being stored here is in hexadecimal format. So that is why it is 211. I don't know whether it is correct or not. So it is in hexadecimal format. Okay. So then followed by next instruction will be, so divide ax by bx. The next instruction address will be, IP will be, so 0a, 10a. Trace again. So what is the value? So 211 divided by 7 equal to 1. So that is the remainder value. Remainder value has been stored here. In this way, so your instructions are going to be gets executed. How this could be gets executed? Let me show you in the next slide. Let me show you. For that you do understand, because you are fourth year students. I believe that you do understand what I'm speaking at this moment. Okay. So what I have shown just before you, that is decode. Directly that decode will be decode debug, not decode, debug. The debug will be directly taken. So decoding is already done because it is directly executing assembly code. So this cycle will be not there with you. This operation could not be there with you. Fetching could be there with you, and execution could be there with you. These two will be there through debug. Okay. So I'm trying to explain with a referral. Now, finally, so at most, as far as sequential algorithms, at most only one instruction could be executed at any moment of time. Okay. Only one instruction could be executed at any moment of time. I'll show you what is this particular thing, and what is a PC, program counter, and how fetching will be happen in the next slide. I'll show you. So when execution of this particular sequential program or sequential algorithm or sequential process, so there might be having some kind of strict operation, that is instruction by instruction where exactly they have been stored. Okay, based on the already we have seen what is the IP value while executing the particular program. Already we have seen. Let us see. You can see this one. This is a single processing architecture. Only one CPU is there. One microprocessor will be there with you. Single microprocessor will be there with you. This single microprocessor will be connected to the system bus. Already I have given some clear information what is the system bus. Control bus will be there within the system bus, and address bus will be there within the system bus, and data bus also be there with you within the system bus. Okay, and the CPU will be connected to all IO devices, and memory, in the sense this memory will be included both the random access memory, RAM, and auxiliary storage device, that is AUX memory. Both will be there within this one, and any monitor or LCD projector, you can take anything here. So the display devices. So single processor will be incorporated within the CPU. Only one microprocessor will be incorporated with this particular system. So this particular system will be executed one instruction at any moment of time. One instruction at any moment of time here. Now, so how the fetch, decode, and the execution could be gets happen here? I'd like to show you using 8086 architecture. Look at this 8086 architecture here. So here you can see there is one particular portion here, that the portion will be the ISBQ, instruction stream byte queue. 8086 ISBQ should able to store 6 instructions which are going to executed. So after present execution of instruction. Presently, some 20th instruction is going to executed. Remaining next, so 6 instructions are going to store within this particular queue. Okay, 21, 22, 24, 25, 26 is going to store at this particular ISBQ, so that one more instruction will be took place or taken by control system, and it could be sent to ALU, arithmetic logical unit. And of course, here arithmetic logical unit will be so connected with many number of registers. Just before I have shown you, AH and AL. This is accumulator AX. This is AX and BHBL. That is BX, and this is CX, and this is DX. Okay. So and then stack pointer, base pointer, stack index, and the data index. Everything has been given to you. Okay. Within this, the bus interface unit will be always able to get the memory, get the auxiliary storage device, or what you call random access memory for most recent 6 instructions which are going to be executed by the specific system. In this way, so the fetching will be gets happen. After fetching, one instruction will be taken by the control system. This could be sent to arithmetic logic unit. Here decoding can be done. Decoding can be done, and execution can also be done here. Execution and decoding can be done at this place. Okay. In this way, so it is actually 8086 because 8086 was introduced in the year 1978, I think. Yes, it is 1978 only. So thereby the architecture will be seems like this. Of course, I am using Core i5 right now, so I don't know how i5 architecture will be. I could not find i5 complete architecture through net also, so it is a bit confused. But here 8086 is pretty much simple kind of architecture. So based on this one only, every architecture has been defined. Okay, it is Pentium 8086. Intel 8086 architecture. Okay. In this way, the instructions are going to be executed. Now, what is the importance of a concurrency? So what are the pitfalls in sequential? Sequential in the sense, first pitfall will be when a particular problem or particular program process is going to start for its execution, no other process is being interleaved. If any interleaving could be there, then that is called a sequential. That is the first disadvantage. And second disadvantage is a cycle of operations could be done continuously, fetching, decoding, and execution. Fetching, decoding, and execution. That could be done. That is the second disadvantage. And the third disadvantage is the sequential operations will be executed on single processor architecture. Only with single processor architecture it could be executed. That is the third disadvantage. And the fourth disadvantage will be, so at most only one instruction could be gets executed at any moment of time, not more than one. So that is also one more disadvantage. So these many disadvantages are there while we are speaking something about sequential. Whereas if you go ahead and talk about concurrency, look at this. So what is the basic difference between a single user architecture? You can see here. Yeah, you can see here. This is the diagram. So this is multi-user, multi-CPU architecture. So we have many number of CPUs have been connected. So here one microprocessor 1, and second microprocessor. This is microprocessor 2. This is microprocessor 2, MUP. And you can able to create n number of microprocessors here. And all these microprocessors will be connected to system bus. And of course, the CPU in the sense, don't imagine yourself that CPU will be a separate box. Please don't imagine in such a way. So in your laboratory, you have CPUs and keyboard and monitor. But CPU in the sense, don't imagine such kind of boxes. CPU in the sense, whatever the microprocessor which has incorporated within the box, that particular box. How many number of microprocessors are there? 2 microprocessors will be there. Then that is called as that is a word. By 4 will be there. Hexa, Xeon, something like that. Many number of names are there. So such kind of orientation will be there to execute the concurrency or concurrent executions here. Then what is the importance of this concurrent in the sense? Same problem. Problem will be same. That particular problem will be divided into several number of pieces. Okay, you have already learned something about Java. In Java, you have threading. So several threads will be there, and those threads will be executed on different CPUs, not exactly one, on different CPUs. Okay. Even then, so those threads or those pieces will be gets executed on different CPUs. You will get so same answer at the end of the execution of whole program. That is the beauty of concurrency. Concurrency's beauty is, so your each and every piece of code will be executed on different CPUs, so that the time will be gets increased, and the values which have been took place between one process to another, one thread to another thread also be gets increased, so that the final outcome will be the same. The final outcome will also be the same here. So in this way, so you are supposed to execute, and it could be executed. So where it could be gets executed, multi-processor or multi-core. Right now, I am using core i5. So in my CPU, I have 5 cores. So it's also be, I mean, core i5 could also be used to execute so concurrency control. If you take Pentium 4, Pentium 3, Pentium 5, Pentium 5 also not having any cores, and then core 2 dual core will be there. So right away from dual core onwards, some 2 cores, 3 cores, and 5 cores, 7 cores, 12 cores, something like that available here. Okay. On these systems, you can able to execute parallel execution. Then, what is the basic point of concurrency here is decomposability. Your problem will be divided into several number of pieces. Each piece will be executed, or each piece will be given to one particular CPU, and they will be executed separately, and they will be provide answer or provide output in a separate type. Everything will be gets combined and will be used or sent to the user. You please remember from design and analysis of algorithms. You please recall yourself that how the divide and conquer will be gets operated. A similar fashion here also. Divide and conquer in the sense. So a main problem will be decomposed into sub problems by identifying its mid. Okay. So 1 to mid will be one sub problem. Mid plus 1 to n will be second sub problem. And again and again and again and again, same kind of operation will be done. After getting some saturation point, and the divide and conquer is trying to combine them. It's similar as it is operation, which could be done here also. So therefore, whatever the operation, whatever the disadvantages we have discussed in sequential, all those disadvantages will becomes to so advantages here. But there are several challenges. Of course, sequential do have some number of disadvantages. Same kind of statements. I mean, same kind of cycle of statements are going to be executed. Fetching, decode, and execution. Such kind of things. Anywhere else that could be there. But so where exactly the faster results will be, that could not be there with sequential. So here in concurrent, they can be there. But there are many challenges. So I'd like to discuss those challenges by tomorrow. Next class, tomorrow's class. So this is actually a small introductory class, which could be gives you some differences between concurrency and the sequential. Tomorrow I shall talk with you regarding to what are the actual challenges which could be faced by concurrency, and why concurrency, what is the basic requirement to apply this particular concurrency, and then how concurrent processes are going to be executed, and how many number of applications are there to be operate this concurrent application, concurrency. So we'll see tomorrow. Okay. So please give feedback on my WhatsApp number. So how you can feel this particular lecture. If it is okay, then I shall continue. Okay. Don't go away. I'll take attendance of you. Don't go away. If you